Hello everybody, and thank you for joining me for question number 25 on the Pascal paper from 2006. So this is our very last question, and we hope to do well on it. John writes a number with 2,187 digits on the blackboard. Now, as an experienced mathematician, I believe 2187 is 3 to the power of 7. I don't know if that's going to become relevant in the question, but that certainly catches my eye right there. Okay, so he writes 2,187 digits on the blackboard, each digit being a 1 or a 2. Judith creates a new number from John's number by reading his number from left to right, which is the normal way we read. Okay, just got to make sure I have the orientation right. And whenever she sees a 1, she writes 112. Whenever she sees a 2, she writes 111. For example, if John's number begins 2112, then Judith's number would begin a 111 for that first 2, then 112 for the first 1, and then 112 for the next 1, and 111 for the next 2. Okay. After Judith finishes writing her number, she notices that the leftmost 2,187 digits in her number and in John's number are the same. So all of John's number looks like the left side of Judith's number. All right. How many times do 5 ones occur consecutively in John's number? 5 ones occurring consecutively. Well, we just take a look at this example. 5 ones occur consecutively here in the first 5 digits if it starts 2112. But the left side of Judith's number has to be equal to John's number. So if John's number, if John's number were 3-digit and were something like 986, Judith's number would have to start 986 and then 52, blah blah blah. But it's this side that counts. Okay, that's the idea. Left side. All right. So, 1 in John's number becomes 112, and a 2 becomes 111. All right. And we're looking for 5 ones together. I think the easiest thing to do is probably start trying to write out a bit of John's number. Now, you might say, well, how do I know what John's number is? And, well, we can sort of understand that his number has to match up with Judith's number as she reads from left to right. And take a look here. Both the 1 and the 2 translate to something that starts with 1. So if John's number started with a 1, Judith's number would start with 112. Well, hey, that does match. But if John's number started with a 2, Judith's number would have to start 111. And already we're seeing things aren't matching. Okay? So John's number must start with 1. In fact, it must start with 1, 1. And then after that, well, I don't know. So let's slowly see if we can work out a bit of John's number. So John's number starts with a 1. Then Judith's number is going to have to go 112. Well, this has to match with John's number, so John's number actually starts 112. And now I can figure out more of Judith's number. We got the 111 from this one, 112 from this one. Then we're followed by another 112, and then a 111. But Judith's number has to match with John's number. So we get more of this. Okay? And so now we get, 112, and a 112, and a 111, and a 112, and a 112, and a 112. And now we can go back and we've got more of John's number figured out. And we can keep going. Now I'm not, because it's going to get a little crazy. But notice for a moment some things. So we've got 5 ones there, we've got 5 ones there. And it's not really happening a whole lot. There's a lot of these 112s that are getting in the way. Okay. Other things to notice, we started with 1, and that gave us 3. But then that 3 gave us 3 for John's number, which then gave us 9. And then those 9 in John's number gave us 27, I believe. So 9, 9, 9, yeah. And so then these 27 would give us 81. So it's going up by 3 each time. So the first sort of n of John's number give the first 3n of Judith's. But you'll notice we're going up by powers of 3. 1 went to 3, went to 9, went to 27, then it'll be 81. So my observation that 2187 is a power of 3, while correct, and it seems to sort of factor into it, I don't quite know how I'm going to use this power of 3 knowledge. Okay. So maybe we should think, well, when do 5 1s occur in a row? Okay, we understand a bit how the numbers are coming together. It seems to sort of be, recursive. You figure a little bit out, you go back, figure out more. Go back, figure out more. Go back, figure out more. That sort of thing. But how can 5 1s occur? So it occurs if we have 2 2s, because that would translate to 1 1 1 1 1 1. And we'll get, and I don't think this will ever happen, but we'll probably have to show why that'll never happen. Or it occurs if we have a 1 and a 2, because then you get 1 1 1 1 1. Sorry, no, a 2 and then a 1. 2 and then a 1. So first, I'll tell you why I don't think this one will occur. 1, I'm not seeing any double 2s happening anytime soon here. It seems like each 2 is at least separated by 2 1s going forward. And that'll actually fit into working with this second one here. But also, how do I count it? 2 2s gives me 6 1s. So is that one occurrence of 5 1s plus a little bit more, or is that 2 occurrences? And then if I have 2 2 2, then we're going to have even more of them. It's going to be harder to count. And that's why I think this will never actually happen, these 2 2s. Okay. What would it take for 2 2s to occur? Well, it never actually will. You'll either have a 1 followed by a 1, and that'll be 1 1 2 1 1 2, or you'll have a 1 followed by a 2, and that'll be 1 1 2 1 1 1, or 2 2s or 2 1s. So you're never actually starting with this 1. You will never ever get 2 2s in a row. Okay, so this is nothing I need to worry about. Every time I see a 2 1, however, I'm going to get 1 1 1 1 1 2. Okay, and then no matter what the next digit is, it will have to start 1 1, and then it'll be either a 2 or a 1. And so that'll give me another 2 1, which will, the next time I use it, give me another 1 1 1 1 1 2. So things are slowly coming together. The number of 1 1 1 1 1 2s is the number of 2 1s that occur. So the number of 1 1 1, and it's for John's number. So number of 1 1 1 1 1 2s. I don't know why I keep trying to put the apostrophe before the N. So the number of these in John's number is equal to the number of 2 ones in the first 729 digits of John's number. Okay. And so now we can ask ourselves, well, how can we get 2, 1? Well, a 2, 1 will only occur if it comes from a 1, 1, 2, 1, 1, 1. And that comes from a 1 followed by a 2. Because you can't have a 2 followed by a... No, actually, you wouldn't. You'd need... So it would either be a 1 followed by a 2, or a 2 followed by a... no, a 1 followed by a 1. Okay. So you can see I'm sort of trying to work backwards from the desired thing that we want, which is 1, 1, 1, or like 5 ones is what we would like. And that'll only happen if you have a 2, 1. So, and then now I'm asking, well, when can I have a 2, 1? And I think I can keep going back like this. I'm wondering if there might be a better way to do this. I'm just wondering if there's some sort of recursion or something. I can't see anything off the top of my head. So, as I say, 2, 1, only when it comes from 1, 1, or from a 1, 2. But I need to have a 1 followed by something in order to get that 2, 1. Notice here, if John's number, if the first 729 digits ended with a 1, all the other ones would produce me 1, 1, 2 followed by some other number, which starts 1, 1, blah. But this last guy would get me 1, 1, 2. And yeah, he's going to be followed by something, but that's not going to translate into a 1, 1, 1, 1, 1, 2 in time to still be in John's number. It'll still be part of Judith's number, but it won't be part of John's number. So the number of 2 ones is equal to the number of ones in the first... It'd be 81, but it can't be the last... No, it's not 81. It would be 243. But we need the first 242 digits, because as I say, that last one won't give me anything. Okay. So now I need to ask, well, how many ones do I have? So ones only occur... Well, actually, now I think we can start getting into a recursion sort of thing. So the first one gives me how many ones and how many twos. So 1 gives me 2 more ones, or 2 ones, and 1 2. A 2 gives me 3 ones and 0 twos. Now I start with 1 1 and I start with 1, 1, and 0, 2s. So this 1, 1 gives me 2 more 1s. Or sorry, becomes 2 1s and 1, 2. So now I've got these 2 1s, each providing me 2 1s, so that's 4 1s. So it'd be 2 times this number plus 3 times this number, so there should be 7 1s and 2 2s. Now 7 2s and then 2 times this number plus 3 times this number, so 20 there. And we can actually go back and double check. You know, in the first 9 we have 1 1 2 1 1 2 1 1 1, so that's 7 1s. And then we'll get 20 here. And then 2 times 20 plus 3 times 7 is 61. Actually, it's got to be whatever's left over, because these have to add up to 1, 3, 9, 27, 81. And now the 243. So it'll go 61, and then it will be 182 ones. And that 182 rings a bell because it's one of the answers. So that's how many ones there are in the first 243. Now I could say to myself, well, yeah, but we wanted the first 242 digits, so there might be one less one. But look at our answers. 182, 183, 184, 185, 186. If there was one less one, 181 would be one of the answers. Okay? So I don't actually need to work that out. More than that, I think after the first one, we end on a 2, then we end on a 1, and then we end on a 2, then we end on a 1, and then we end on a 2. So we'll just work that out. 1 ends in a 1. Then after the first 3, we end in a 2. After the first 9, we end in a 1. After the first 27, we'll end in a 2, because this 1 becomes 112. After the first 81, we'll end in a 1. And after the first 243, we'll end in a 2. So that last digit in the first 243 is going to be a 2. So the number of 1s in the first 242 digits is the number of 1s in the first 243 digits, which will be 182. Each of those 1s, because it's followed by something, produces a 2-1 in the first 729 digits, and each 2-1 produces 5 copies of 1 followed by a 2. Okay, so I'll just 243rd digit is a 2. So our answer is 182, and that's A. A times in John's number, there will be 5 1s and then a 2. Although they only asked for 5 1s, but it has to happen 5 1s and a 2, because I've already said you're not going to get 2 2s in a row. All right, so that was an interesting question. It really was. I liked it. I didn't know where they were going with it. My observation of 2187 being a power of 3, well, that was still true, and it came out from the problem. It wasn't obvious that I needed to know that. The fact that I noticed that right off the bat after reading the question had nothing to do with my solution method. Because I noticed it was going 1, and then we get 3 in Judith's number, and that gives us 3 in John's number, which gives us 9. And so you can quickly see we're multiplying by 3 each time. I like that there was a combination of working backwards, so from the 5 1s and the 2, to it's got to be a 2 1 in these first digits, which has got to mean this number of how many 1s there are in the first whatever digit. So that was working backwards, but then it also became, can I count how many 1s? Can I count how many 2s? And that was pretty nifty. So we needed to sort of understand the rules, that from each 1 we get 2 1s and a 2. From each 2 we get 3 1s, and that allowed us to count the number of 1s and 2s really fast, even though I didn't know their order there. Okay, good question. I liked it. I liked the 2006 paper overall. Next up will be the 2006 Fryer, if you're looking for more grade 9 level stuff, or the 2006 Cayley, which is more multiple choice, but it's aimed at grade 10. Okay? So, in the meantime, good luck with your math, your practicing, and everything else you guys are doing. Have yourselves a wonderful day. I'll see you later.